Hello, my name is Clinton, the Tech Pro, and today we are going to continue with another lesson, another data structure in our data structure for programmer series. And today is going to be Splay Trees. So as I mentioned, this might look boring, it might look uninteresting, but I recommend you make sure you follow it because you need to know what actually is happening or the principle behind what you are doing as a programmer. So this is about the 7 data structure I've discussed so far, and I think I'm targeting to be able to cover about 15 to 20 data structures. So Splay trees are self-adjusting data structures. Of course, they are binary trees. They are binary search trees for sure, a variation of binary search tree, just like an AVL tree. The only difference or the key difference in Splay tree is that it performs another operation called splay each time a search or an operation is carried out. It performs an additional operation called splay. So that is this operation called splay. So for instance, if we perform an operation that says search X, is going to, in addition to this operation search X, also perform splay X. So what happens is it makes it possible that the item that an operation was performed on is now bubbled up or moved up to the root. So the easiest thing to understand it is to use an example. And before I mention this example, let me also mention that, let's take for instance, let me just give an example before I continue. So we have, let's say we have X, Y, Z. For example, if Z is retrieved, let's say Z is retrieved and found, it means that Z have to be moved up to the root. So instead of X, so Z will then be moved up to the root. But in this case, we also make sure we maintain the binary search tree of operation. So this is what we'll have at the end of the day, Z, and with respect to X and Y, we will now have maybe X, Y in both directions. So we have Z, we have Y, we have X. So at this point, Z becomes a root. So let's take a real example. Before I mention this example, the type of rotations that are performed in a Splay tree, there are a number of them, and they have a peculiar name. For instance, we have the zig rotation. I guess this zig rotation corresponds to right rotation, and we also have the zigzag rotation. And then we have the zag rotation, and so on and so forth. So let's take an example. Let's take, for instance, we have this tree. Let me see if I have, okay, have this tree. We have Y. Sorry, let me draw something better. Let me use a different kind of thing. Okay. So let's take, for instance, we have Y. What happened? So I use a bigger size. So let's say we have Y and we have X. Okay. Again, I'll change the color to this. Okay. So no. So okay, I think I have it now. So let's say we have Y, X. So this is a tree. Circle this. And there are some subtrees, let's say A, we have, this is C, and we have B. So when we perform something like, let's say we perform a zig rotation, what is going to happen is that X will move in this way and Y moves down. And again, one thing I want to let you know, when a rotation is performed, the relative positions of the subtrees are the same. So C will remain to the left to the right of Y, and B is going to remain to the right of Y. A is going to also remain to the left of X. So let's see. So we are now trying to bubble X up the tree, so x now becomes the root of the tree. Y goes down, and y goes down in this way. So let's see y. So what happens to the children? Again, C is a child of y, is a subtree to y. X has a subtree of A, and B now becomes a subtree of y. Anyway, I would like you to play around with this. I would like to tell you about something else, something called potential, right? I think that's his name. Something called potential function. So let me just mention it. Potential function is something of course, you should know. How do we calculate the potential function? The potential function is a theory that helps us to try to figure out the energy that is released when a node, an item is bubbled up or moved or splayed up from the leaf to the root. So it says that the theory goes this way, that each of the nodes has arbitrary weights, Wi, for each of the nodes. Also, for each of the nodes, we have a metric that defines the size of all the descendants of that node. So summation of the weights of all the descendants of a node is given by S X. So this is weights of descendants, weights of descendants. This is weights of nodes. Then we have a metric called the rank of a node. Rank of a node X is the summation of all the weight of all the descendants. So we have the summation, and the summation or the log of X. Actually, I'm going to write it in a bit clearer way. Log of X. Okay. So now this is the rank of a node. That gives us now the potential function, which is represented with phi. Phi in this way is given by sum of the ranks of the nodes. So that is the potential function of this tree, sum of the ranks of all the nodes. For xi, for I is equal to 1 to n for all the nodes in the tree. So somehow it may be confusing, but I would like to recommend try to take some time to understand what is happening. I actually will not go too far in this theory, but just take note that the key point we've mentioned here, that the Splay tree is self-adjusting, is a binary search tree. It performs additional operation called spray by means of rotations, zig rotation, zag rotation, and zigzag rotations, and so on and so forth. And also we have the potential function to be, first all the nodes have a weight assigned to it. Then you can calculate the sum of the weight of the descendant of a node. It gives us x for node x. I can then calculate the rank of a node to be the log of the sum of all the weight of all the descendants, and then you go ahead to calculate the potential function to be the summation of all the ranks of all the nodes. So basically that is what Splay Tree is all about. I'm going to stop here, and I'd like to thank you for viewing. If this has been informative for you, please like it and also subscribe to my channel. Leave me a comment to let me know what you would like me to do. Maybe have some particular data structure you'd like me to discuss. Also let me know.